GATE 2017 set 2 electrical question number 3. So this is giving us that the figures show diagrammatic representations of vector fields x, y and z. Which one of the following choices is true? There are three vector fields x, y and z given as shown in the figures. So you have to guess which of the following options are correct. So they are basically asking divergence and curl of the following vector fields to be 0 or non-zero. How to identify them intuitively, because these are diagrammatic representations given of the vector fields, and you have to intuitively tell about their divergence and curl. That is just to tell if they are 0 or non-zero. So to deal with such problems, first you need to understand divergence and curl physical significance. So divergence of a vector field means the tendency of that vector field to diverge either outwards or inwards. For example, if you are given a vector field like this, then as you can see, this vector field is going out and in. So if you take an imaginary surface enclosing this vector field, the net influx or net outflux, that is divergence, can be commented as 0 because nothing is net coming out or going in. So similarly, if you see this example and you take an imaginary surface, you see everything is coming in, so divergence exists and is not equal to 0. For case 2, let us say this is 2 and this is for 1, this is 1. So here divergence is 0, here divergence is not equal to 0, and also divergence is a scalar quantity. Remember this. Now coming to curl of a vector field means tendency to rotate. If a vector field has rotation, its curl not equal to 0. If it's irrotational, then its curl equal to 0. So for example, if a vector field is like this and the arrows you see, they're having a rotation like this, like clockwise rotation. So for clockwise rotation, the curl is into the plane and negative curl not equal to 0. So rotation exists, so curl not equal to 0. Similarly, for anti-clockwise rotation, curl is positive. similarly not equal to 0. No rotation means curl is 0. So these useful data will be needed to predict intuitively their divergence and curl. So first case, second and third, x, y, z. So x is like this. So it is very easy. You can see if you draw an imaginary surface enclosing this vector field x, then you will see that net outward flux exists. So divergence of x not equal to 0. So divergence of x is not equal to 0. Similarly for y you see and z, for y and z you see y is like this. So there exists clockwise rotation, and for y and for z also there exists some clockwise rotation. So since these vector fields are having rotation, then what we can tell, curl of y not equal to 0, curl of z not equal to 0, implies curl is not equal to 0. This is y, and curl of z not equal to 0. So curl has direction, and remember it is a vector quantity. So we find that curl of y is 0 not equal to 0, curl of z is not equal to 0, and divergence of x not equal to 0. So coming to the options, you see divergence of x not equal to 0, curl of y not equal to 0, curl of z not equal to 0. So option C is the correct option. Thank you.